All right, so we're going to take a look at hyperbolas. Hyperbolas have two focal points. They look like that. It's the difference of the distance from the foci to any part of the hyperbola is exactly the same no matter what point you choose. So unlike an eclipse where you're adding, hyperbola is a difference. And it's mainly used in cooling towers of power and nuclear plants. All right, so they're very similar to eclipses. There's only like two major differences. Instead of an addition, you have a subtraction. And it also has isotopes, right? So isotopes are these diagonal lines that kind of guide the hyperbola when you're actually graphing it. Everything else is pretty much the same thing. So you do have vertical hyperbolas and you have horizontal hyperbolas. Um, Aside from the isotope with the vertical, your A is up and down, right? So, and your vertices also, then your focus points are there. And then horizontally, you'll have your B. If it's horizontal, then everything is a horizontal except the co-vertex and your B, which will be vertical. All right, so very similar to ellipses. Hyperbola is just a negative sign and isotopes. Okay, so we're going to take a closer look. All right, so where do you put this negative? All right, so hyperbolas have similar properties to ellipses. The only new thing is that it has a subtraction sign, and it also has isotopes right here. And these isotopes are used to guide the hyperbola. The biggest thing for you to realize is where to put this negative sign. Okay, so go ahead and write this down. If it's vertical, in other words, it opens up and opens down, you would think it has to do with the y-axis, right? But what you're going to remember is that the negative goes with the opposite. So because I think it's y, it's going to go with the opposite, so that's x. And you can see that the negative goes with the x. Okay, same thing if it's horizontal. If it's horizontal, I would think it's x, but the negative goes with the opposite. So opposite of y would be y. So the negative goes with the opposite. So if it's horizontal, it goes with y. Unlike the ellipses, okay, what you need to remember is look at this order of a squared and b squared stays the same. So the only thing that determines the direction is where you place this negative. Okay, so you make sure you place the negative with the opposite, and then a squared and b squared stays in that order no matter which one you're actually writing. Okay, so that's really all you have to keep in mind, but everything else is the same. So just looking at it, the isotopes are diagonal lines that guide the curves. There they are. The vertices are turning points, are A units. So you see that distance? A units from the center. So the whole axis is 2A. All right. The co-vertices are B units, just like before, B units. The foci are C units. And of course, the transverse axis, because that's the major axis, the distances in the vertices, is 2 times A. And the conjugate axis, which is like the minor axis, is 2 times B because it's 2 B's. All right, the formula this time to find C is opposite of the ellipse. So instead of it being C squared, is A squared minus B squared. It's going to be A squared plus B squared. So you do need to know the difference between the two. An ellipse is minus, hyperbola is plus. Okay, so let's go ahead and graph an hyperbola. So is it horizontal or vertical? It's horizontal. Y. Negative is attached to the y, so it's actually x, which is horizontal. The center is 0, 0 because there's no h or k. All right, now we're going to calculate what a is, which is the square root of 121, and b is the square root of 36. So we're going to count 11 to the left and right. Those are my vertices. And we're going to count up and down 6. Those are my co-vertices because I know it's horizontal, right? So let's write down the coordinates of the vertices. So it's going to be negative 11, 0 and 11, 0. The length of the transverse axis, remember transverse is like your major, right? So it's the length of the vertices from each other. So it's 2 times a, which is 22. And your conjugate is your minor, which is 2 times b, so 2 times 6, which is 12. All right, the coordinate of the foci points, all right, so you have to use the new formula. So instead of minus like ellipses, we're going to do plus for hyperbola. So it's going to be 6 squared equals b squared plus a squared, or a squared plus b squared, doesn't matter the order. So that's going to be 121 plus 36. That's going to give me 157, and then c, remember, is the square root of that because we got to take square root of both sides. So c is equal to the square root of 157, which is approximately 12.5. All right, so I'm going to draw that in, so about there and there. Okay, so those are my foci points. All right, those coordinates are negative 12.50 and positive 12.50. All right, so let's explore isotopes. So we need to graph the isotopes and write the equation for the isotopes. Now remember, there are two ways of graphing lines, right? Equations of lines. In order to make this really simple, we're just going to draw a box around the vertices and the co-vertices, right? So draw a box all the way around so you can see where these equations of lines go through. So it's going to go from diagonal to diagonal. So this is one isotope here. And then the other diagonal to the other diagonal will give me the other isotope. And you can notice that they go through the center. So your isotopes go through your center. It just happens that this center is in 0, 0. All right, so to find the equation of a line, remember there are two ways we could do this. We could do, you need 2 points. So I can write the point, let's do negative 11, 6, and we can do the origin 0, 0. All right, and we can use the formula y minus y1 equals m parentheses x minus x1. So this is the first way of doing it, and you just pick the way you prefer to do it, okay? Label x1, y1, x2, y2, and then just plug it in. So y1 plugged in is equal to the slope, which is y2 minus y1 over x2 minus x1, and then x minus x1, which is that. All right, go ahead and simplify. So that's y minus 6. That simplifies to positive 6 over 11, negative 6 over 11, I'm sorry, and that's going to be x plus 11. All right, go ahead and distribute the 6 over 11 into the parentheses, and we can also move that minus 6 to the other side. So that's going to give me negative 6 over 11x plus, and when you multiply this out, you're just going to get the negative 6. And then moving the negative 6 to the other side is going to be plus 6. So simplify that equation, you're going to get negative 6 over 11x plus 0. So 0 is nothing. So we found the equation of this line right here, of this diagonal line. So now we're going to find the equation of the other diagonal line. And I'm going to use a different method, right? So instead of using the point slope formula, we're actually going to use y equals mx plus b. Don't worry about writing these points down. I'm going to ignore them in a second. All right, so let's write that in the equation. Y equals mx plus b. Remember, m is slope and b is the y-intercept. And again, how do I find slope? Rise over run. So b, the y-intercept is 0. And then the slope, which is rise over run. So I'm going to rise from 0 to 6. And then I'm going to run 11. So my rise is 6, my run is 11. And simplifying that, you're just going to get y is equal to 6 over 11x. So whichever one your preference is, use that. All right, so I'm just going to label the two diagonals. So now given A, B, C, and the isotopes are ready to graph it. So we know it's horizontal, so it's going to go this way, right? And the vertex is going to touch that actual point right there. So we're going to graph it that way, use the isotopes not to touch the hyperbola. There you go, just like that. And that is my horizontal hyperbola for this equation. Now, what do you notice about this patterns of the isotopes? So let's look specifically at the slope, 6 over 11 and minus 6 over 11. Obviously, the opposite of one another, but look at my A and B and compare them. So what do you see? All right, so we're going to write this down for the horizontal. What do you see about the slope? I see that the slope is B over A for one of the line, and the other line is negative of that. So negative B over A. And that's actually a relationship that's going to stand true. So for a vertical one, and we'll use this a little bit later on, for vertical ones, so it's actually going to be the opposite of what you think. All right, so if it was B over A, it will now be A over B and negative A over B. Okay, so that's the relationship with the slope of the isotopes. That way you don't have to actually do it. All right, so you go ahead and try the second question, see if you can graph the hyperbolas. Let's practice.